Okay, before I enter, I just want you to recall back this question. Do you remember in the last lesson, we were looking at this question? Hold on, because I need to write something, so I have to off my video right now. Okay, so I need to carry on. Now I go back to this. Okay, you have any idea about this question 3 that we have done before? Do you still remember? A total of H males and H minus 2 female visit the museum on a certain day. If a total of visitor for that day is 80, what is the value of H? You still remember? This is in checkpoint 1. Hello, do you still remember?
Yes.
Yes, okay. So if you look at this, H plus H minus 2 equal to 80. Have you learned this before? In your primary school? Yes or no?
No.
Okay.
No.
Okay, don't worry. This is what okay, thank you for answering. So don't worry, this is what we are going to learn today. It's related to our new chapter, that is linear equations. Which chapter are we entering into today? Chapter 6. Yes, correct. Very good.
Chapter 6.
Yes, correct. Thank you. So we are going to look at linear equation. This linear equation is divided into 3 main subtopics. So you can see chapter 6, linear equation. Sorry, my handwriting is very messy here. Okay, we are going to look at 3 subtopics in this chapter. The first one is linear equations in one variable. Okay, and then the second one, we are going to look into linear equations in 2 variables. The last one is simultaneous linear equation in 2 variables. Simultaneous over here means we have 2 linear equations and then we are going to solve it together. So in BM, it is called serentak. Kita selesaikan masalah itu serentak. Okay? So now we look into 6.1, the subtopic for 6.1. What are we going to learn in this first subtopic? Here we have to find out what are linear equations in one variable. Like just now, you don't know what is it, right? For that question number 3. So we are going to look into what is a linear equation in one variable. That is the first thing. It is also exactly the same as the first subtopic that we have. Second, we are going to form linear equation. You are going to generate linear equation from a situation given. And then the third one, we are going to solve linear equation. You are going to learn 3 methods today. So make sure you bear in mind how to solve all of it. And then the last one is the solve problem. Means they give you a problem, you solve it. Okay, so we are going to look into these 3 main parts first today. Okay, the rest we are going to extend it in the next lesson. Okay, let's look into chapter 6. So this is what you have in your book, right? So what you will learn, so you are going to learn these 3, the 3 subtopics that I've mentioned just now. Okay, why do we still study this chapter? So this one, you can read yourself lah. We are going to save our time over here. Okay, now I need somebody to read this. Okay, let me see who is here. Shazira, can you help me to read the first paragraph here? Make it bigger. Shazira, are you there?
Yes.
Okay, this one. Any problem with your mic? Okay or not, Shazira? Cannot, Okay, if cannot, move to Anis. Anis, are you okay, Anis? Anis, Hayani.
Yes, madam.
Okay, your voice is very clear. Good. Can you help me to read the first paragraph here?
Sure.
Yeah.
21st century learning is one of the implementations in Malaysia Education Blueprint (PPPM) 2013 until 2025. In the 21st century classroom, the students are arranged in groups to enable them to hold discussions and carry out various activities. For example, a class consisting 30 students is needed to be arranged in groups to achieve the goals.
Okay, thank you very much. So this is the blueprint of Malaysia from 2013 to 2025. The students is arranged in group for discussion. Okay, for example, a class consisting of 30 students needed to be arranged in group to achieve the goal. I'm sure you all did this in your primary school, right? You were divided into a few groups and then you are given a task to solve the task. Have you ever do that?
Yes.
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 Yes, right. It's fun, right? You get to know new friends and so on. Okay, but then you cannot do it in our school yet because you know like with the pandemic right now we cannot sit in group. But after it's over, then most probably next year or in Form 3, then you can do that again. Okay, let us continue with the next paragraph here. I want to ask somebody which is seldom here today. I think Ahmad Dawisi is here. Ahmad, can you hear me? Dawish, can you read this paragraph here? Dawish, can you read this paragraph? It is given.
Madam, he said his mic is broken.
Okay, then I change to somebody else. Timothy. Timothy, you are not going to the restroom today, right?
Yeah.
Yes.
Yeah.
Okay, carry on with this paragraph.
Oh my god. Paragraph, okay. It is given that the number of boys in a class is 6 more than the number of girls. How do you determine the number of groups that can be formed such that each group has 2 girls?
Okay, thank you very much. So from here, it's a very long question here. It is given that the number of boys in the class is 6 more than the number of girls. Do you know how many number of girls over here?
No.
Don't know, right? So this is like the previous chapter, the algebra expression. If we don't know how many numbers of girls, then we have to make assumption. So let X be the number of girl, for example. So girl will be X. And then the number of boy is 6 more than the number of girl. If the number of boy is 6 more than the number of girl, so the number of boy is X plus 6, meaning the number of girl plus 6 because it is 6 more than the number of girl, right? Okay, now you look at the question. How do you determine the number of groups that can be formed such that each group have 2 girls? So we have X girl, but we don't know how many of the total right now. So this is what you are going to learn in this chapter. You are going to try to form up the equation and then we are going to solve it. Okay, let's look at the mathematician involved first, huh? I think Timothy. Timothy, can you off your mic for a while? Is it Timothy? Okay, so this is the mathematicians involved, Diophantus of Alexandria. Okay, Diophantus of Alexandria was a Greek mathematician who contributed significantly to the knowledge of solving algebraic equations. He was known as the father of algebra. So for more information, you can scan into it and search online. Okay, this is the word link that you are going to learn in this chapter. Trial and improvements. Okay, this is a method, meaning it's kaedah cuba jaya. You keep trying until you get the answer. And then equality, maksudnya kesamaan. Numerical value, nilai berangka. Working backwards or backtracking, pematahbalikan, meaning that you are going from the back to the front. So working backwards. And then variable, you know this already, variable is just like X, Y, Z, it's form boleh ubah. Okay, and then substitution is kaedah penggantian. Elimination, penghapusan. You eliminate something, so you hapuskan. Solution, penyelesaian. Linear equation, persamaan linear. So this is the linear equation that you are going to learn. Simultaneous linear equation, persamaan linear serentak, and root of an equation, punca persamaan. Okay, don't worry, this might be new to you, so we are going to enter into it later on. Okay, let us carry on with the second page here. Okay, so first we are going to look into linear equations in one variable. So what is this? What is this, class? Can you identify what is this?
100 ringgit.
100 ringgit, right? And then this is also 100 ringgit, right? 50 plus 50.
Yeah.
Okay, so they ask you to see into this that amount of money in this diagram A and the amount of money in diagram B over here is equal. Okay, so this situation can be written as the amount of money in diagram A is equal to the amount of money in diagram B because both is consisting of 100 ringgit. So the equal sign, this symbol is used to show the relationship between two quantities that have the same value. And then the mathematical sentence that involve the equality is known as equation. So equation maksudnya dalam bahasa Melayu adalah persamaan. For example, x plus 2 equal to 5 and y minus 7 equal to 11. We call this equation. Okay. So let us look into the exploration activity over here. We need to identify the algebra expressions and equation. So we are going to identify over here. Okay, they ask you to observe the mathematical sentence. This, they call it mathematical sentence over here. And then they ask you to classify the mathematical sentences into expressions and equation. So this one is expression, this one is equation. Copy and complete the circle map below. Okay, we don't have to do that. We just try to identify them, classify them into this expression and equation. So you've got to bear in mind when it comes to equation, what is the symbol that we should have? Any idea?
Equal.
Yeah, the equal sign. So very simple. You just need to look for the equal sign and everything will be in this classification. So let us look into the first mathematical sentence, 7h plus 2. In which one, expression or equation?
Expression.
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 7h plus 2 is in expression. What about x plus 5 equal to 8?
Equation.
Equation.
X plus 5 equal to 8 is an equation. As long as you see the equal sign is equation. Y over 2 minus 10 equal to 11, which one?
Equation.
Equation.
Correct. So I write it down here. The next one, k squared plus 1 equal to 6.
Equation.
Equation. And then 6p plus 4q equal to 9.
Equation.
Okay, we have a lot of equation over here. Okay, we move to the next line here. X minus 2y over 3 equal to 7.
Equation.
Equation. Okay, what about the next one? 3n plus 1 equal to 6n.
Equation.
There's really a lot of equation. 5a cubed minus 4?
Expression.
Expression, very good. What about the next one? 3h minus 1 equal to 5k?
Equation.
Correct. And the last one, what is it?
Expression.
Yes, expression. X plus 2x expression. Okay, so after this, we are going to see there are altogether 6 equations because not 6, 1, 2, 3, 4, 5, 6, 7 equations that we have. Okay, we move into the next page, so that you can see what are actually there showing over here. Okay, these are the 6 equations that we have. Just now we have 7, right? But they just show 6 over here. So first one is x plus 5 equal to 8 until the last one, 3h minus 1 equal to 5k. Okay, you look at the equation here from the activity. These equations are known as, is somebody calling me? Magdalene? Yes, anything, Magdalene? You're not calling for me, Okay. So these equations are known as linear equation. since the power of the variable is 1, you can see the variable over here, the power, if they didn't write down anything, meaning that it is 1, x to the power of 1. Same with the y over here, the variable is 1. And then 6p plus 4q over here, the variable is also 1. 2y and x over here is also 1. The next one, the variable for n, and this one is also 1. H and k, all of it is 1 because they didn't write down 2, 3, 4, 5. So we called it linear equation because of the variable is 1. But then among all 6 of these, okay, it is found that there is one variable and the power of the variable is 1. This one. Okay, what is the difference? Okay, the difference is like this. We have one variable over here. This one also one variable, but then this one we have 2 variable. This one also 2. This one, n and n is a 1. H and k different, right? So we have 2. Okay, remember this chapter we learn linear equations in one variable. So the one with 2 variable is out. We are not going to look into this. We are not going to look into this. And we are not going to look into this. That's why we have these 3. Okay? These 3, we call it linear equations in one variable. Okay? Can you remember this? Linear equations in one variable. Okay, because there's only one variable here, one variable here, one variable here. Because they are the same, we consider it as 1. Okay, so this equation, how to identify it, you just remember, in that equation, we only have one variable. So this is one variable. And then the power must be 1. When the power is 1, we call it linear. Okay, this is the basic one you learn because following in Form 2, Form 3 later on, you are not going to learn the linear anymore. You are going to learn something like this, x to the power of 2, x to the power of 3. Okay, but now you are learning the linear one, meaning the value of the power of the x is 1 over here. And then we have equal sign, so we call it equality. So the whole mathematical sentence over here, we call it linear equations in one variable. Are you okay, class?
Yes.
Yes.
Okay, let's move to example 1. We look at example 1. I'm going to discuss this with you. Explain whether each of the following equations is a linear equation in one variable. Without looking at the solution, don't look at the solution first. A, 3x plus 2 equal to 5. How many variables are here?
1.
Which one is the variable?
3x.
X is the variable. X is the variable, not 3x, x only. How much is the power for the x?
1.
If they didn't write down means it is 1. And then there is a equal sign, the equality over here. So this is a linear equations in one variable. So you can see the solution given because the equation has one variable x and the power of the x is 1. Okay, now we look into B. Is this a linear equation in one variable?
No.
2 variable, right? P,
Yes.
Q. So this is no. What about the C over here? Is it linear equation in one?
Yes.
Right, because it's only one variable over here. So this is a yes, this is a yes. What about the last one?
No.
No. Why?
Because have
Because there's
power of
power.
Yes, very good. Because there is a power of 2. We cannot have a power of 2. The power must be
1.
Yes, 1. Okay, now we look at the right-hand side over here. They ask us to discuss over here. Discuss whether each of the following equation is a linear equation in one variable. So again, we are learning this linear equation in one variable. X equal to 0. Yes or no?
No.
How do we have a variable?
Yes.
Yes. How much is the power of the variable?
1.
Do we have
1.
equality? Do we have equality?
Yes.
Yes. So this is a linear equation in one variable, although it's very simple, x equal to 0. Okay. Now we look at B. 1 over x plus 2 equal to 6. Is it a linear equation in one variable?
Yes.
Yes.
Okay, you
Yes.
say yes, right? But then the answer is no. Why no? You've got to remember the value of the variable cannot be the denominator. If it is down there, actually the value of the variable, the power is -1 because it's at this part over here, denominator. Unless they write down x over 3 or any other number plus 2 equal to 6, x as the numerator, then yes, it is a linear equation because the power of the x is 1. Okay, so you bear in mind, the value of the variable cannot be at the denominator. Can you remember that?
Yes.
Yes. Okay, what
Yes.
about C, class? C, this one. Is it a linear equation in one variable?
No.
Yes or no? Yes.
Yes.
Just guess. Yes. No.
Yes.
Okay. Some say yes,
Yes.
right? The answer is no again. Why no? Because although it looks like the power is 1 over here, I rub it off so you can see clearer. Although it looks like the power of 1, but then we need to multiply. You see, this is a bracket, right? So x times x becomes what? X times x is x squared. X squared. So the power is not 1 anymore. Therefore, this is not a linear equation in one variable. Are you okay?
Yes.
Yes.
Yes. Okay, let's move on to example 2. Okay, in this example 2, we are going to see how to form linear equation based on a situation given. Okay, this is the one. So we look at example 2 here given. You have to form a linear equation in one variable for each of the following. You already know what is a linear equation in one variable, right?
Yes.
You know this, right? Okay, so we are going to look into this, how to form it up. Subtract add from a number. Its remainder is 2. So do we know what is the number over there? Do you know what is the number over there? Don't know, right? So for the number that you don't know, we always need to make a sum.
Assumption.
We always need to make assumption. So let's look at A over here. Okay, I'm going to move it up. So I'm going to assume the number is equal to x. So let x, or let the number be x. It's very hard for me to write here. Let the number be x. Okay, now subtract, add from a number. We refer back to the question again. Subtract, add from the number. The number is x right now, right? The remainder is 2. Do you know the meaning of remainder?
Baki.
Yeah, baki dia, betul. So you can form up already. You subtract the add from the number, meaning it is x minus add. Bakinya ialah 2. So we form up the equation in linear equation in one variable already. The power of x is 1, and then we have equality. So that's all for question A. Easy, right?
Yes.
Okay, then we move on to question B. Pek Chin bought 5 pens, which cost Y cents. So you got to imagine there are 5 pens. Each of it is 5 cents. I don't know why they use the Bahasa Melayu cent. Supposed to be CENT, isn't it? Okay, never mind. And an exercise book which costs RMT. So there is an exercise book RM3. Okay, the total amount that she paid was RM7. So you can imagine already, she buy the pen, she buy the book, and then the total is 7. So how are we going to represent it? Okay, if the pen is 5 cents, so cheap, can you get a 5-cent pen right now? Anywhere? No, right?
No.
So it's really cheap already. So you got to remember over here, the unit must be changed to the same unit. This is cent, this is RM. Either you change the cent to RM or you change the RM to cent. But then you got to remember, if you change the cent to RM, it will be RM 0.05. So later on in our equation, you will have to simplify it again by changing it to a whole number. Remember, your equation must be always in whole number. That will be the simplest form. So I'm not going to change this to 0.05 because I have to go through another step to change it into whole number later on. So I'm going to change the RM3 into cent. RM3 equal to how many cent?
300.
300 cents.
Yes, very good. And the total that she paid RM7, I'm also changing it to cent. How many cent?
700.
Yes, correct. 700 cent. Okay, so from here we can form up the equation already. 5 pen with 5 cents each. It means the price of the 5 pen will be 5 times. 5 cent. There's no 5 cent. It's Y cent. Sorry, Y cent. Okay, 5 pen with Y cent. It will be 5 times Y. That will be the price for the total 5 pieces of pen. Correct or not?
Yes.
Okay. Yes, How many exercise books?
1.
1, because from the word N over here. So it means 1 exercise book. So 5Y plus 1 exercise book means 300 cents. So you don't have to use 1 times 300 because this one we understood already. 300 means 1 exercise book. How much is the total? How much is the total?
700.
700 cents.
700 cents. So it's done already. We got the linear equation. Okay, you got to remember when you format linear equation, remember don't put the unit cent. Don't write down cent and then over here you also put cent. That will be wrong because each of the letter over here will be considered as variable. That's why you cannot put the unit in. Okay, we only can have a variable. So remember, no unit. So do you have any question for this one?
No.
Okay. I'm going to move to example 3. So this example 3, just now you were asked to form up linear equation which consists of 1 variable. So now it's the other way around. You need to write a statement or a situation from the given equation. So you are given the linear equation in 1 variable, you have to change it to statement. Okay, don't worry, there are many types of statement that you can change. So the one that given is just a example for you. So for example, 2x plus 5 equal to 19, where x is a number. So to change it into a statement, you can say twice a number because the x is a number over here. So 2x means twice a number. If it is 3x, what do you call it? If it is 3x, how do you call? Again, I heard somebody said it right.
Thrice.
Yes, very good. It is thrice because it's 3 times the number. Okay, so you can see plus 5 over here. You are going to use the sentence added to 5. Okay, added to 5. The result is 19. Okay, so equal to 19. You also can say it's equal to 19. Twice the number added to 5 equal to 19 also can. Or the total is 19 also can. Okay, now we look at B. Y minus 2 equal to 8, where Y is the edge of the Rajesh now. Usually they will give you the information for the unknown over here, the variable. So they tell you Y is the edge of Rajesh. Okay, so you are going to make use of the edge of Rajesh over here. So the solution will be Rajesh was 8 years old 2 years ago. Okay, you see, Y is the edge of Rajesh. Minus 2 meaning that 2 years ago, right? That is his age equal to 8. So Rajesh was 8 years old 2 years ago. Okay? Or another way you can do it, you can say 2 subtracted from a number. See carefully, 2 subtracted from a number. The result is 8. Also can. Okay? But then because they give you the condition already, if they give you condition like this, then you cannot use the one that I explained to you just now unless they didn't give you the condition like this. This one is not given. They just give you this. So you can say 2 subtracted from a number, the result is 8. Are you okay, class?
Yes.
Yes.
Yes, okay, we try to go through the 6.1
Yes.
together over here. Try to go through together. Let us see how to solve each of the question over here, because later on you need to try out on how to solve it. Okay, number 1. Form a linear equation in one variable for each of the following. A, the quotient. You know the meaning of quotient? I've told you before. Still remember? Do you still remember, class? Don't remember, huh? Quotient means hasil. Hasil apa? Hasil apa? Bahagi. Bagus. Hasil bahagi. Okay, the quotient of a number and 6 is 12. So can you imagine? Quotient of a number and 6 is 12. How should I write down the linear equation in one variable? Because this is required, linear equation in one variable. Okay, so the quotient of a number. Do you know the number? You don't know the number, right?
No.
Quotient of a number and 6, this line over here, it is represented in this way. The quotient of a number. So you make assumption, let the number be x. A quotient of the number and 6 means x over 6, it is equal to 12. That's all. Okay? That's why I need you to practice this together, because it's not easy. Okay, now B. The price of chicken is RMY per kilogram. You imagine, chicken, Rosita bought 5 kilogram of chicken and made a total payment of RM40. Okay, so this one is simple. How many kilogram of chicken did she buy?
5.
5 kilogram. And then the price is RMY. So it will be 5Y. The total payment is equal to
14.
5Y to the 40. Okay? Now I continue with C. The perimeter of a rectangle. So you imagine a rectangle. Do you still remember what is perimeter?
Yes.
Yes,
Yes.
perimeter meanings you add up all of the length, the width, and the length and the width. You add up everything. So that's the perimeter of a rectangle with length 2x. Okay, so I write down the length is 2x, the width is 5. So 2x is in centimeter, and then the width is 5 meter. You see, the unit is different right now. So you got to change it to the same later on. So the total, you see, the perimeter of a rectangle with length 2 centimeter and width 5 meter is 14, meaning that the total is 14 meter. Okay, now, are you going to change the meter to centimeter or the centimeter to meter? Which one?
Meter to centimeter.
Centimeter.
Change to centimeter, right? Okay, 5 meter equal to how many centimeter?
500.
500.
5,000, not 500. Oh, remember. 500, sorry, you are right. I thought it's kilometer. Thank you. You are better than me already. What about 14 meter equal to how many centimeter?
140.
140 to
1,400.
1,400. Very good. Remember, 1 meter is equal to 100 centimeter. Okay. Now, can you form up the linear equation already? For C, can, right? The linear equation is, how many x do we have? If this is 2x, the opposite side also 2x. This is 5m, the opposite side is over 5m. So, 5m is 500, remember? Okay, how to get the perimeter first?
Add
Add up everything, right? You add up the whole thing. So, 2x plus 2x, how many x?
4x.
Right, 4x. And then this one represents 500 centimeter. 500 plus 500, how much?
1,000.
1,000.
Yes, very good. 1,000 equal to the total. How much is the total? 1,000.
1,500.
We form up the linear equation in one variable already. You see, one variable, the power is 1, and then we have equality. So it's done. Are you okay?
Yes.
Okay, now we move to question number 2. Question number 2, write statement or situation for each of the following equation. Okay, so we have A over here, P minus 1 equal to 6, where P is a number. Can you think of a statement on how to write for this situation over here? P minus 1. P is a number, so minus means subtract, right? So we make it easy. Subtract 1 from a number.
The
The
result
result,
is 6.
yes, very good. Okay, you can do that already. Wow. Okay, let's look at B. X plus 10 equal to 78, where X is Adri's score in a text. Okay, so they give you the requirement over here. X is Adri's score, so you have to mention about Adri's score. So how are we going to use Adri's score over here to describe the statement over here?
LG score is added by 10.
Correct? You can say Adri's score is added to 10 because the next one you say added to. Okay? Added to 10. So again, how to mention the rest? This one?
And it equals to 78.
Okay, it's equal to 78 or it will be 78 or you can say the result is 78. Okay, there are many possibilities that you can use. Okay, now we look at C. For M equal to 50, where M is the mass. So the M over here, it is the mass in kilogram of a peck of rice. Okay, so this one simple, right? How are we going to make from the situation given? How to write the statement?
A pack of rice is mkg.
A pack of rice is mkg. Not correct because you have 4M. You have to mention this. Okay, I give you solution one of it. You can say 4 packs of rice is 50 kilogram. Are you okay? Or you can say the total mass of 4 packs of rice is 50 kg. Because I told you the mass is in kilograms. So 50 over here means 50 kilogram. I repeat the answer. The total mass, I write down now so that you answer clearer. The total mass of what? Total mass of what?
Pack of rice.
You have to use 4 because there are 4. 4
Four
packs
of rice.
rice. Very good. Is how much?
50 is
Yes, it's 50 kg. Okay, you got to put yourself into it. 1 pack of rice, 10 kg. 4 packs of rice, 50 kg. Okay, have you ever go and buy the rice together with your parent from the supermarket? Heavy or not? 1 pack of rice?
Yes.
Right. Okay. So let's move on. Now we are entering into number 3. Let's see. 6.1b. Okay, I'm going to continue with solving linear equation here on the right. This one. So we just learned how to form the linear equation from a given situation just now. Now we enter into the third one, how to solve linear equation in one variable. Okay, if you look at the diagram given over here, this is x kg, a block over here. And then we have another block over here, which is 6 kg. Okay, and then you can see the scale over here, the weighing machine here, it shows 10 kilogram. So the reading shown by the scale over here is equal to the total mass of both of the blocks. Okay, therefore, the linear equation that is formed is equal to how much? Do you know or not? The linear equation is x
plus
plus
6 equals to 10.
very good, equal to 10. Ignore the unit. So you can see there's no unit over here. Okay, now if we replace the x kilogram over here with a block of a mass of 4 kg, I replace it. Okay, so the reading will show 10 kilogram. Okay, this 4 over here, I write down properly. This 4 over here, it shows the numerical value that satisfy the equation of x plus 6 equal to 10, right? So we call this 4 over here is the solution of the linear equation. The 4 over here, it is the solution. Okay, and then the solution, we also call it the root of the equation. The root, kalau dalam bahasa Melayu tu root dipanggil apa? Root dipanggil akar kan? Tapi dalam bahasa matematik, root itu dalam bahasa Melayu dipanggil akas. Bukan akar ya. Okay, so you don't have to worry first. Now we are going to learn on how to solve the linear equation. You just remember, once you found out the answer is called the solution. And then the solution is actually the root. You are going to use this word in the higher form later on, 2, 3, 4, 5. Okay. Now, to solve linear equation, there are 3 methods that you need to learn. Okay. So we don't have to go through this. Okay, this is the one. The linear equation in one variable can be solved by using 3 methods. The first method is trial and improvement method. You still remember the meaning dalam bahasa Melayu tadi? What is trial and improvement? Still remember?
Cuba jaya.
Bagus. Cuba jaya. What about the second one? Application of equality concept. This one tak ada dalam word bank lah, but never mind. We are going to go through later on. And then backtracking method. Backtracking. Masih ingat?
Pematah balikkan.
Pematah balikkan. Bagus, pandai kamu semua. Okay, we look at example. So we need to go through, I just let you know, we need to go through all the 3 types of method. But then the best one for you to learn is this one. So I'm just going to go through these 2 with you so that you know how to apply it if some such kind of question came out in the exam later on. Okay, now we look at the first example. Example 4 here. Solve the linear equation 2x plus 1 equal to 7 by using trial and improvement method. B, application of equality concept. And C, the backtracking method. So to solve this, they ask you to use all the 3 types of method to solve it. So we go through the first one, A. 2x plus 1 equal to 7. Using trial and improvement method, meaning you are going to find out the value of the variable. When they ask you to solve, meanings that you have to find the value of the variable, the x over here. So how to find it out? You are going to keep trying. For example, I assume the x is 1. So 2 times 1, how much is 2 times 1?
2.
2 times 1, 2, right? And then when we plus 1 is equal to 3. I didn't get 7. Okay, I don't get 7, so it's not correct. I will keep trying again. The number is very low, so I'm going to try with a bigger number. 2 times 2 plus 1. So 2 times 2 equal to? 4, right? 4 plus 1 is 5. I still don't get the answer, but I'm almost getting it over here. So I'm going to increase the number again. So I keep trying. That's why they call it trial and improvement method. So 2 times 3 right now, how much is it? 6. 6 plus 1, 7. Yes, I got it. Therefore, the solution or the value of the x is equal to 3. Okay? So we call it trial and improvement method. This one easy, right? You understand, right?
Yes.
Okay, thank you. We understand. So you look at the little bug down here. What did he say? Linear equation in one variable has only one solution. It means there is only one answer for linear equation in one variable. So you bear in mind now, you won't have other answer. You only have one answer. X equal to 3, that's it. There's no other answer like x equal to 3, x equal to 5. No, only one answer. Okay, now we carry on with the second method, that is the application of equality concept. Okay, it's down here. With the figure. Don't worry, I'll explain to you slowly for these ones. This is the one that we are going to use. Okay, so originally the linear equation is 2x plus 1 equal to 7. They represent it in the form of diagram. You can see 2x plus 1 equal to 7. 1, 2, 3, 4, 5, 6, 7. Okay, now we want to get the value of x. Hold on. We want to get the value of x over here. So what do they do? You see, there is a common thing. The common thing is the one in circle in pink color. So we are going to eliminate each. So that is still balanced. It's not like one heavier and then one is lighter. Okay, so both you minus 1. So you can see from here we minus 1. 7 minus 1 equal to how much?
6.
6, right? Okay, same with this one. 2x plus 1 minus 1, we have 2x remain. Okay, so you can see after you minus 1, the remaining is 2x over here. 7 minus 1, we have 6 right here. Okay, now to solve it, we can see both can be divided into 2 equally. So the 2x plus 2x equal to 6 will be divided by 2. So divide by 2 like this. And then you can cancel already. So 2x divided by 2, we get x. It's like this, 2 times 1, 2, 2 times 1, 2. So we only have an x. And then 2 times 1, 2, 2 times 3, 6. So we get the answer, x equal to 3. Okay, we are going to try some more question like this later on. This one is shown in diagram to make you understand, but we don't have to do so. We just have to solve the working only. Okay, now we move into the backtracking method. This one you understand? Do you understand this one? Yes, roughly, don't worry, roughly. Later on, I'm going to teach you further about it. Okay, we go through backtracking method. Backtracking means that you go backward. So same question here, 2x plus 1 equal to 7. So we have to make the initial value equal to the variable, the x, and the final value is 7. So whenever you see the equation like this, you are going to take out the x, you are going to take out the 7. This is the initial value, this is the final value. Okay, so you look at this line here. How to get 2x? The x have to be multiplied by 2, so we get 2x. And then plus 1, so you can see plus 1 over here, equal to 7. Okay, so the x will be here, the 7 will be here. You put it in first. Okay, the next thing is you have to use the reverse operation. What does it mean? The times 2 over here, you change becomes divide 2. The plus 1 over here, you change becomes negative 1. So when we get the answer, it will be like this, x divided by 2 minus 1 equal to 7. But then it will be backward now. Backward, you can see the arrow. Okay, so it will be 7 minus 1. We get 6. 6 divided by 2. So we get a 3. That is the backtracking method. Therefore, we get the value of x already. It is equal to 3. Are you okay? Can or not? Can or not?
Yes.
Yes, okay, I give you another example for backtracking method. X minus 3 equal to 5. So which one is the initial value? The initial is x, right? The final value is 5, right? So we write down first x 5 like this. Okay, so the operation, the next one is minus 3. We just have to write minus 3. Okay, this is going from right and left to right. But then we are going to use the backtracking method. So we write down the x and the 5 first. Okay, the negative 3 will be what? Negative 3 will be what? No idea. Negative 3 will be what, class? It will be the reverse positive 3. See, reverse operation. Multiply by 2 becomes divide by 2. Positive 1 becomes negative 1. You reverse it. Okay or not? So the 5 is at the back. I'm going to do it this way right now to get the answer. So 5 plus 3, how much? 5 plus 3, how much? Are you still there? 5 plus 3, how much? Yes, very good. It's 8. Okay, meaning the value of the x is 8. So you can check back over here for the first the line here. The x is 8. 8 minus 3. Is the answer equal to 5? Yes, right?
Yes.
So you can get the answer already. So that is backtracking method. Okay, now can you repeat the 3 methods that we have just learned? Repeat again, everybody repeat together after me. Read after me. Okay, where is the line already? Where did I put? Now everybody have to repeat after me, so that you're familiar with it. Let me see, where is it? It's here. Okay, we learn 3 methods. First, everybody on your speaker. There might be a dog barking or anything. Never mind, just turn it on. Okay, first, trial and improvement method. Read.
Trial and improvement method.
One more time. Trial and improvement method.
Trial and improvement method.
Okay, next. Application of equality concept.
Application
of equality concept.
One more time. Application of equality concept.
Application of equality concept.
The last one. Backtracking method.
Backtracking method.
Yes, one more time. Backtracking method.
Backtracking method.
Okay, good. Now we carry on. So now I'm going to look into this one. Solve, this is the last part, don't worry, because we already reached 10:56 right now. Solve the following equation. So we have 2x plus 13 over 5 equal to 7. When you have a fraction like this, you got to remember you have to change it into just one line. Okay, one line, what does it mean? It means you have to change it into a single line, like just now, 2x plus 1 equal to 7 in a single line. Okay, so you see we have 2 lines, the fraction with the denominator over there. So we don't want that because if you do like that, you cannot solve it. Okay, so you copy down the question whenever you need to solve it. Now, in between 2x plus 13 over 5 equal to 7, the one that we can solve is the denominator. Divide by 5. To cancel divide by 5 or to simplify it, we multiply by 5 like this. So when you multiply by both sides. Okay? When you multiply by both sides, it's like this. 5 cancel with 5. 5 times 1, 5. 5 times 1, 5. So the remaining will be 2x plus 3. You can see it here. 2x plus 13. Sorry, not 3. And then 7 times 5, we get 35. So this is the form that we want. Just now I told you we don't want it to be a fraction form like this. I want it to be a single line. Okay, when it is in this form, the next thing that we need to eliminate is, you look at this, we have 3 terms. First, second, third, we have 3 terms. To get the value of x, we want this one first. So we need to eliminate the 13. Okay, so on both sides, we minus 13. So 35 minus 13, we get 22. The 13 here, you minus 13, 2x remain. Okay, so 2x is equal to 22. Now, I want to get the value of x only. So, I have to eliminate the 2 here. How to eliminate it? I'm going to divide it with 2. So, when I divide here, I'm going to divide on the right. So 22 divided by 2, I get 11. The 2x divided by 2, 212, 212, the remaining is x. So we got the answer already. Okay? Or, if you don't want to do it both sides like this, I always teach my student a simple way, whereby when you have 2x, I write down up here. When I have 2x plus 13 over 5 equal to 7. So I'm just going to move this to the right. Divide by 5 becomes multiply by 5. So it will be 2x plus 13 equal to 7 times 5. Okay, so 7 times 5 is 35. So now I'm going to move the 13 here to the right. So it will be 2x remain. 2x remain. When I move the positive 13 to the right, it becomes minus 13. Okay, so continue from there. 35 minus 13 is 22. So 2x is 22. Okay, so I want to get the x only. I'm going to move the 2 to the right. This is everything moving to the right. So 2x over here means 2 times x, right? When I move the 2 over, it will be divide. So it will be 22 divide by 2. Because it's a times over here, you send it to the right, it becomes divide. So I get the value of x is 11. Like this also can. It will be easier for you to solve everything. Okay? Like this, if you understand, also can. But then you have to do redundant work. Both sides you have to multiply, both sides you have to minus, both sides you have to divide. It's up to you which one you want to choose, up to your understanding. Okay, now we move to the next question, the last one here. 5 in bracket x minus 4 equal to x plus 16. So whenever you have bracket, you have to expand it first. You know the meaning of expand?
Besarkan.
Apa? Besarkan kah? Bahasa matematik dalam bahasa Melayu, expand ni dipanggil kembang. Kembangkan. Okay? So expansion means pengembangan. Pengembang means that you have to multiply. So 5 times x, we get 5x. 5 times 4, we get 20. Okay? What is the value that we want to get over here? You need to identify first. What is the value that we want to get? Of course, we want to get the value of the unknown, the variable. What is the unknown over here?
X.
Yes, we want to get the value of x. Okay, so you see x appear on both sides. Later on, we have to gather them together. Okay, so the first thing, what do they do? By using the, this is the application of equality concept. Because we have negative 20 over here, to eliminate it, negative 20 plus 20. So no more, this one, no more. And then if you plus 20 here, you also have to plus 20 at the back. So 16 plus 20, we get 36. Okay, so far you understand this one?
Yes.
Yes, Okay, next thing, you see we have 36 and then we have an x over here. So they want to move the x to the left. I'm not going to talk about the left and right, sorry. I'm going to deduct the x from here because I don't want the x appear on both sides. So they will deduct the x, means x minus x, so no more x. Okay, and then this side also you minus x. So 5x minus x becomes 4x. So the remaining will be 4x equal to 36. Then to get the value of x, I'm going to eliminate the 4. So to eliminate it, I'm going to divide by 4. So 4x divided by 4, 4 times 1, 4, 4 times 1, 4, the remaining is x. And then the 36 also divided by 4, 4, 1, 4, 4, 9, 36. So we get the solution already, the x is equal to 9. Are you okay?
Yes.
Yes, Now I give you a simple question.
Yes.
X minus 10 equal to 3. Can you tell me what is the solution for x? You have your answer already? Okay, I'm going to show you the working for the application of equality concept. X minus 10 equal to 3. So I need to get the value of x. I have to get rid of the 10, right? So x minus 10. How do I get rid of the negative 10? Plus 10, right? I want
Yes.
0. So next, on the right, I also have to plus 10. So it will be x equal x and negative 10 plus 10, nothing left, equal to 3 plus 10, 13. So I get the answer already. Or if you use my method, the left and right method, left and right, x minus 10 equal to 3. I want to get the value of x. I'm going to move the negative 10 to the right. So x equal, you remember, for this linear equation, all the equal sign is in the middle. You don't give me the equal sign in front like this. In front like this, that is not correct. The equal sign are all in the middle, bear in mind. Okay, now I carry on. So when I move the negative 10 to the right, the 3 I copy down first. Negative 10 move to the right becomes positive 10. It's always the opposite. If divide, move to the right, become multiply. Multiply, move to the right, becomes divide.
Divide.
If it is positive, you move to the right, becomes negative or minus. Okay, so you can see 3 plus 10, we also can get the answer, 13. Understand?
Yes.
Okay, I'm going to try another question with you.
Yes.
4x minus 1 equal to 7, so that you understand. 4x minus 1 equal to 7, so I write down. I'm going to use the application of equality concept first. So from here, which one should we eliminate first? Which one?
Negative 1.
Very good, because we need to get the value here, so we need to keep this. Okay, so it will be 4x minus 1 and plus
Plus 1.
Okay, and then the right 7 plus 1.
1.
So these two already eliminate. So the remaining is 4x. The equal sign again in the middle. 7 plus 1 is 8. Okay, now what do I eliminate? I should eliminate
4.
Very good. I should eliminate 4 so that I can get x only. So this is 4 times x will be 4x. How do I eliminate it? I'm going to 4 times x becomes divide by 4. You divide by the same number that appear here. Okay, so the 8 will also be divided by
4.
Yes, very good. So 4 divided by 4, nothing left. The remaining is x. 8 divided by 4 is 2.
2.
So it's done. Okay? Or you use the left and right method that I show you. I always show these two methods to the student because in upper form later on, you have to use the left and right method. It will be faster. Okay, I'm making it fast for x minus 7 minus 1 equal to 7 originally. So I'm going to move. Okay, this is about moving left, right. Moving this to the right. Negative 1 move to the right becomes?
Positive 1.
Very good. Copy the 7 first and then positive 1. So 7 plus 1 is 8.
8.
So 4x equal to 8. Now, because I want to get the value of x, I'm going to move the 4 to the right. So x I write down. Okay, 8 I copy down. 4 times x, when I move the 4 to the right, becomes?
2.
This is times, right? Times becomes divide by 4. Then you can get the answer already. 8 divided by 4? 2.
Divide.
Okay, so that's the difference of these two methods. This is the one that's shown in your book. This is the one that I show you myself using the left and right. You just move it to the right. Negative, move to the right, become positive. Okay, and then if multiply, the move to the right becomes divide. Are you okay?
Yes.
Yes, right?
Yes.
Yes, any question?
No.
No.